this video, we're going to look at a couple things we're going to need to know how to do with hyperbolas. Given an equation for a hyperbola, we're going to need to know if it's vertical or horizontal, meaning does it open left and right or up and down. We're going to need to be able to identify vertices and foci for the hyperbola. We're also going to need to identify the equation for the asymptotes for the hyperbola. As you can see on the screen here, we have two different versions of the equation that we can use. The first is this equation written in white pen. That's x squared divided by a squared minus y squared divided by b squared equals 1. For this type of hyperbola, our hyperbola is going to open horizontally, left and right. It's going to have vertices at positive negative a comma 0 and foci at positive negative c comma 0. And no matter what shape the hyperbola has, to find c, we're going to use the Pythagorean theorem. You can see that in green. C squared equals a squared plus b squared. The blue equation represents a hyperbola that's going to open vertically, up and down. And there we have y squared divided by b squared minus x squared divided by a squared equals 1. And here our vertices are at 0, comma, positive negative b, and our foci are at 0, comma, positive negative c. But our asymptotes are still going to be the same. We're still going to find that value c for our foci in the same way. So let's look at two examples. For example 1, we have this equation, x squared divided by 25 minus y squared divided by 11 equals 1. So I want to identify vertices, foci, asymptotes. So first of all, for my vertices, I'm going to use the value that is underneath the positive term. Since x squared is our positive term, that means that this opens left and right. And since the value underneath the x squared is a squared, for my vertices, I'm going to take the square root of that, so my vertices are at positive or negative 5, comma 0. For the foci, we're going to need to do a little bit of algebra. So we're going to start by saying that c squared equals a squared plus b squared. So just those values that are in the denominators of our fractions. That, of course, is 36 in this case. So c equals positive or negative 6. So our foci are at positive or negative 6, comma 0. Finally, for our asymptotes, we're going to take the square root to the values of the denominator. And in this case, our asymptotes, there's always two of them, are going to be at y equals positive or negative square root of 11 divided by 5x. So I'm just taking the square root of the value under the y, that always goes in the numerator, and the square root of the value under the x, that goes in the denominator. Once again, this represents two equations. The positive, the one with the positive slope, square root of 11 over 5, and the one with the negative slope. So here on the graph, we can see what this hyperbola looks like. It opens left and right. And if we chart our asymptotes and look at the equations, we can see that we get, for our asymptotes, square root of 11 over 5x and negative square root of 11 over 5x. And for our foci, we get positive and negative 6, comma 0. Once again, for those asymptotes, you can see that as the graph gets, as we zoom out on the graph, we see that the shape of the hyperbola really approaches the shape of those asymptotes. For our next example, we're going to look at a hyperbola whose equation is y squared minus x squared divided by 9 equals 1. In this case, because the y squared is the positive term, that means this is going to open vertically. It opens up and down. So that means for my vertices, our vertices are going to be on the y-axis, and we're going to use the number in the denominator of the y term, which in this case, since there is no number, we can always put that y over 1. So my vertices are at the square root of 1, which means 0, positive or negative 1. For the foci, we're going to use the Pythagorean theorem again. So c squared equals 1 plus 9, that's a squared and b squared, which is 10, which means c equals positive or negative square root of 10. And so my foci, once again, because it's vertical, are on the y-axis, so we get 0, positive or negative square root of 10. And for the asymptotes, I'm going to use the b and the a values, and so we're going to get y equals 1 over 3, because I take the square root of both those terms, x, and we have two asymptotes, both the positive and the negative. Here's what that hyperbola looks like on the graph. We can see it's vertical, it opens up and down. Our vertices are at 0, 1, and 0, negative 1. And if I turn on my asymptotes and my foci, see that the asymptotes are at 1/3 x and negative 1/3 x. We have the square root of 10 for the foci. We can see the decimal approximation that's used there on the graph that represents the 0, square root of 10 and 0, negative square root of 10. So that's how to find vertices, foci, and asymptotes for a hyperbola.